those solar standards they are coming out in the market. Either I've written them or reviewed them or approved them on behalf of the standard committee. And it's not just the technical aspects. We, being an engineering firm or anyone engineer joining this event, we might think that engineering aspects is very fancy, very fantastic. Of course it is, but without a commercial element to it, those engineering can stay just on the desk, on the table. And I mentioned about AI and machine learning algorithm, a portfolio that we have looked at in India, just over 300 megawatt of project. And that has resulted of on average 10% uplift in generation, but that's from technical point of view. The benefit that has resulted from financial impact point of view, over 20 million pound of benefit just in 1 year because of additional generation, additional revenue, but also reduce some level of contractual obligation, for example, liquidity pay, damages, etc., etc. And then this extra generation that has additionally offsetted over 33,000 ton of CO2. And we have we have been a finalist for British Renewable Energy Award last year under 2 categories, smart energy systems and innovation. And while doing all this exercise, we have created some level of global partnership, global footprint by signing some MOUs with, for example, TS Redco, Telangana State Renewable Energy Development Corporation, another company in Vietnam, Viet Energy Efficiency Platform Joint Stock, and an IPP in Turkey. And we have been working quite collaboratively with the UK government, Indian government, across different bilateral programs. What we do, we manage project risk. If I cluster them into 2 different categories, operational assets and new build development. We'll go through a little bit more details, individual aspects that covers different journey towards or different aspects of different technologies, different innovations into net zero journey. Now, this is a journey. I think that is what we need to recognize. There are so many policies across the different market. There are COP26 commitment, etc. If we wanted to achieve net zero tomorrow, that's not realistic, because what we wanted to do, we do not want to compromise our day-to-day life. That is why I think one thing we need to understand very clearly is the transition, is a journey. Question is how quickly we cover that journey, how quickly we transit towards net zero, or maybe very quickly we would be talking about zero emission rather than net zero. So we as a company, we work with developers, asset owners, lenders, different corporate development corporations or commercial industrial customers. Technology perspective, mainly solar, any form of solar related to utility scale, commercial industrial rooftop or ground mounted system or floating solar. Battery storage, it could be just standalone battery system, but also can be integrated with existing solar or PV and wind system. And very recently, about 2.5 years ago, we started working towards EV charging infrastructure or solar EV concept. These are the different services from design optimization, value engineering, technical due diligence, asset optimization, repowering, and testing and commissioning. We'll go through a little bit more details within this. So when we talk about design optimization, and like I was saying earlier, me being an engineer, we always feel like we wanted to do fancy things. Of course we do. We love doing that. But it's more of a holistic approach is needed for all engineers when they're doing a design of a system, taking into account what are the components to be used, whether that component is available from supply chain risk point of view or from engineering solution point of view, but at what cost. So more of a techno-commercial assessment will help to get that particular design or system or solution that you are preparing on your desk, on your laptop, will go into the field and be deployed more commercial value addition point of view. So that is what my suggestion would be for all engineers attending this, doing a design, focus on not just engineering, but commercially how that could be attractive. Here are a few examples. For example, when that project came to us, it was a 46 megawatt project. I know this particular context is related to the building environment, but this is a similar concept, similar solution can be applied whether it's a ground mounted system or for a building integrated system or application into different commercial or even domestic applications. So particularly when that project came to us, it was a 46 megawatt project with different kind of design philosophies that we apply that has resulted increasing further capacity in the fixed area with the fixed grid connection cost, etc., etc. So that would then ultimately help commercials of that particular project to fly quicker. Another example, the rooftop project, when that project came to us, it was a 1.1 megawatt project with, by selecting different design, different tilt angle, different configurations, we increase to 1.7 megawatt. This is just a few examples, but essence, what I'm trying to say is please keep in mind engineering and commercial aspect together as one bundle. Technical due diligence, whether that's a very early stage feasibility or tender stage like DPR, project development support, energy yield assessment, engineering design, or going into construction audit, construction management. So the project that we covered, like I was saying earlier, mainly commercial, industrial, and utility scale, and project sizes really varies between few hundred kilowatt system of rooftop to largest project that we have done so far in New Zealand, just over 350 megawatt. Now, here I'd like to run a poll. Himanshu, if you could bring up the first poll before actually we move into the next topic, which is related to more of optimization of solar asset. So the question is, I'm sharing my screen. I'm not sure whether I'll be able to see the poll. Himanshu, if the poll is up, if you could just give a thumbs up. Or maybe I'll go in here. Yeah, Himanshu, if you could bring up the poll.
Poll is up.
Okay, so yeah, if you could see that, how many of you think that your solar system, or you are aware of other solar system, they are performing to their expected level? Probably allow about 30 seconds or so for people to think and click. Maybe 5 more seconds. And Himanshu, if you could just share top 2 ranking of that poll.
Yeah. So 53 attendees has replied out of 131. You can see the result.
I don't see it because it may be because of I'm sharing it, my whole screen. That's why. So which one is the top 2 one?
1 minute,
Which
1 minute.
bracket?
1 minute. Now you are able to see?
No, I still don't. Oh, I do see now. Yes. Okay. Right. So 75, so 33% is under, did I understand that correctly? So 333%.
So basically 22 out of 53 are suggesting 25 to 50%. So
right.
42%
Okay.
is basically suggesting B.
Understood. Okay. Interesting. Reason is what we have seen so far, I'll share that in a second. What we have seen so far, um, reality probably it's towards lower bracket. Many people are facing loss of generation of their existing solar assets. So this is where why this problem is there in the market, because we have been so busy building project, and we all know how price sensitive different markets are, and there are a lot of compromise happened in the past. So that means we are double paying for those systems, because of this lack of or loss of generation compared to their expected values. So one must see more of a holistic point of view, just to see the overall system efficiency improvement. How? By doing a condition monitoring or health check at a very granular level of the individual component, and the outcome of that will help to optimize the existing process of an individual asset owner, that will then help to take a more informed technical and commercial decision going forward. So I mentioned about AI and machine learning algorithms. Now, what are those? We should not be driven by those terminologies of different buzzwords like AI, machine learning. They are largely driven by different mathematical formulas. How customized those formulas are, particularly for the technology that you are using, but also how do you do or what you do with those outcomes. So taking a more informed decision is more important. So including data analysis, including site intervention, etc., is very much mandatory requirement. And with this exercise, we have seen, like I said earlier, about 8%, just over 8% on average uplift in generation in Asia and Europe. Here are a few examples. So that 300 megawatt of project that I was mentioning earlier, portfolio project mentioned earlier in India, this is the average 10% uplift happened. And you can see the spectrum of improvement between 6% to 16%. And the age of those plants is not really that old when we looked at in 2017-18, less than 2 years old. When it comes to similar exercise in Europe, we see about 8% uplift in our portfolio that we have looked at, but the age difference was a little bit older, these projects. What are the reasons behind it? So lessons learned, what we have observed is it could be related to module, but not always just module. That is another problem in the market. We think that if system is underperforming, then is because of module related issue, and we go into more of litigation, etc., which is a longer time taking process. But there could be some pragmatic and practical approach one must take to really see the benefit of their investment that they have made in the first place. So other things could be cable, could be connectors, particularly connectors is one of the key reason for underperforming those solar systems, whether they're a commercial industrial rooftop system or domestic system or utility scale system. Inverter obviously is another cluster, and particularly cleaning is so challenging on rooftop projects. So taking that into account in the first place when the system get designed. This is our global footprint of our PV APM, PV asset performance
Jyoti,
management.
sorry to interrupt. There are a lot of
Hmm.
comments. Your screen's not shared. If you could share it back again.
Okay. When that shared, do I need to go back, and what was
No,
the
that's
last?
fine. That's fine. We can go ahead.
Okay, so this is our global footprint, and what I can say, this underperformance of issues, it's not country specific, it's a global problem. And that is where asset owners across the globe are quite taking a decision how they will safeguard their investment that they already have made. If you don't do it, it will result into repowering of your system. That means you double pay of your system, and that repowering could come at different format. It could be changing module, changing inverter, changing transformer, or combination of few things, which is more complex. When you do a design or redesign of an existing system, technically is more complex, but also commercially challenging, and maybe compliance point of view into different market, that what is the capacity that you have already signed up with, depending on your contractual obligation, etc. And that is why more rigorous testing, more rigorous quality assurance measures at execution phase is absolutely necessary. And I'm just only covering few pictures here, focusing on the DC side of the system, which tends to be abundant baby of a solar system. we tends to focus more from the AC side testing point of view. So focus on both sides, DC and AC, is quite mandatory requirement, making sure your system is running as expected. This is another solution, particularly for commercial industrial space, a tool that we have developed to test more of techno-commercial aspects of solar and battery storage projects for captive project. So how do you do it? So initially, we should take a load assumption or load pattern of a premises that you are working with. Then you do your design, and then you do your modeling, that what is your generation models looking like, how that match with the demand profile. And then you can decide, depending on amount, quantum of electricity that you're exporting or consuming, do your battery sizing accordingly. So then you can take more of a commercial decision going forward. Our footprint of over 8 gigawatt of project, we mainly work with institutional investors, international developers, and asset owners. And a market research, independent market research company, Gemserve, who has done a research on us compared to our friends out in the market in terms of company ability and product completeness, particularly for Southeast Asian market. And they put us in the leaderboard of that metrics. Now, here I'd like to run the second poll. So if you could bring Himanshu the second poll, which is related to EV charging or EV infrastructure. So is the power green for your EV that you are driving?
Sorry, shall I?
If you could run the poll, yes, Himanshu.
Yeah. So can you see the poll?
I can see poll has started, but I don't see exactly.
Yeah, it has started. Yes.
Okay. Yeah.
People have started reverting.
So yeah, let's allow again around 30 seconds. Maybe 5 more seconds, and then if you could reveal the score, Himanshu.
Yeah, 1 more minute. We'll take 2 minutes, so total.
The men's is just around this corner, on the other side.
What is the result, Himanshu?
Just a minute.
Yeah, that's right. This is regarding, there was a question, this is regarding EVs on the road that we see.
So yeah. Can you see the result?
No.
1 minute. So we have 42. So majority of the people have answered A. 0 to 25%. Let me just see. I'm unable to share the result. So majority of them have answered A.
Yeah. So
And
that's correlate. That's really correlate with what we expect to see or what we are seeing in the market. So I think answer is there. We know where the contribution of electricity to our society, and still large proportion of electricity still come from coal. So that means if we, even though we are driving, while we are driving, there is no emission, but when you're charging, that electricity is not necessarily green electricity. So we might be emitting somewhere else, but not be polluting where we are driving. So that's the reason we have developed a zero emission EV charging infrastructure, or solar EV in that concept. And that was particularly developed under a UK-India program called Innovation for Clean Air, IFCA. And very first project we have deployed in ISC campus in Bangalore. So what I'll do is I run this video, and can you just tell me if you could share my screen and also can hear the voice?
yeah, you can play the video. We can't hear the audio.
Okay. So Himanshu, if you could play that.
Sure.
Yeah.
One minute, huh?
Mhm. EV are getting deployed, but the question that we are asking today, that the source of power to those electric vehicles, are they green? And most of the time answer is no. Hi, this is Jyoti Roy, founder and CEO of Green & Co. Under Innovation for Clean Air program supported by Energy Systems Catapult in the UK, we have designed, developed and deployed a solar power EV charging infrastructure project. We have deployed this project at ISC campus in Bangalore by using local supplier, local installers, and the feedback is quite encouraging from the users that they are using these charging stations. They think this low carbon or zero carbon emission charging station creating a big environmental impact, and they are feeling good by using this charging station. Next, we are installing this solar power EV charging station in Chennai at British Deputy High Commissioner office.
Wait. Don't skip. User authorization. If you have ever worked with it, you know how complex and tedious it can get. We have all been there. But we as a team...
Yeah, if you could stop that one, that was not the intent. So the concept really is you produce electricity and you charge your EV to make it as close as possible towards zero emission EV or solar EV infrastructure. It could be, this particular project was an off-grid project. It could be on-grid, could be off-grid, and it's very modular. We all know how solar system can be a modular system, and whether it could go in a rooftop or it can go in a carport where we park our vehicles. But if there is a space constraint, particularly when we have selected this particular project in ISC campus, finding a site in Bangalore, and that was the greenest part in Bangalore. Of course, we do not want any disturbance to the existing trees, so that is why we changed this rooftop system, carport system to a rooftop system. And next, like I was saying earlier, so what we have done is, this is the UK embassy in Chennai, and it's a very small system, just 6 kilowatt system. But again, this is just a concept. It's a modular but conceptual system. It could charge 2-wheelers, it could charge 3-wheeler, it could charge 4-wheeler. And when I was there during July month, there was a delegates was coming from cabinet ministers were explaining part of the G20 program to demonstrate this particular project. But again, this could be domestic application if you are using your EV, because all EVs coming in the market these days, I'm talking about 4-wheelers, they are offering about 100 plus kilometer, and in our day-to-day life we barely covered that journey. So we could easily go in the office, come back at home, and we charge our vehicle at night. Of course, when you charge that vehicle at night, you need an energy storage to store that electricity that produced during the daytime. So there are a lot of things that you can play with, but to really create that or prepare the transition towards a net zero emission related to transport sector, which is the second largest contributor to this climate emergency after power sector. So there is a lot of room for everyone to play a role and contribute towards this climate emergency that we are facing. Few other examples. So this is a solar EV charging infrastructure project. So this is the theoretical concept which has now deployed. It's a rooftop solar and then carport area, and it was designed for one of the largest global e-commerce company, and different scenarios that we have modeled of different type of EV charger, so 6.5 kilowatt AC charger, and different charging hours. So battery sizing can be designed accordingly. So there's a holistic approach one need to see, but that could really supply close to 100% of their electricity demand. This is the warehouse which covers about 3 megawatt, and this rooftop area covers about 1.5 megawatts, so totaling 4.5 megawatt system. Few other case studies of our due diligence exercises that we have done: a 43 megawatt system in the UK, Romania, another over 150 megawatt system. That was one of the New Zealand project, 184 megawatt. A due diligence small project, 10 megawatt in India. Asset optimization. So this is one example we already have seen in the past in that bracket of average 10% uplift in generation. Rooftop example, an utility company in Switzerland. Another asset optimization of UK project. Now, this one particular case study is related to utilization of land. So this is a landfill solar project, which I think becoming quite or potentially becoming popular in India when there is a land scarcity and land utilization factor, etc., coming to a debate. But there are different measures one must take. Few additional survey, few additional consideration to consider, but there are a large number of projects that is happening across Europe at the moment, utilizing all those old landfills. They might be inert landfill or might be coming towards the end of their methane gas production from those sites. But those lands are available. Certain level of additional technologies or additional studies, etc., will help to utilize those land for better uses. I'll leave that here. Any questions that you may have, whether now or towards the end, depending on the agenda. But thank you for your time. So just covering through little journey that we have been through in last 6 years with Gridenco. Thank you.
Thank you. Amitji, are you there? I think he is lost. So what I would suggest, if you don't mind, we'll just take few questions. Two questions we have, so that since you are in UK and if you have some other commitment, after that we'll go to the next presentation. So we have two questions for you.
Please.
Yeah, 1 minute. So one of the attendee, Mr. Himanshu Tanvi, has asked about less than 25% of projects have solar performance. So please do let us know how you conclude the result and what sort of factors affected for such low solar performance.
It's a range of different aspects. Let me quickly share my screen and the lessons learned topic. So it really ranges from module to cable to inverter. I'll give you a couple of examples. Project in Rajasthan. When we're analyzing the data, we saw during summer months, certain combiner box was producing nearly less than expected value. But the same combiner boxes was not producing that less compared to expected value in winter months. So what that triggered in our mind, It could be cable sizing issue. So what we have done, because what do you request? We always request for providing as-built design details so that we can map the whole plant, we can do full cable sizing calculation. And then when you have requested our partner, because we always call them partner rather than a client or customer, to provide the cable settling, and it was clearly visible those combiner boxes was underperforming over 50% during summer months. There was 50% undersizing cable went in. So when the irradiance was higher, it was producing more, but because of the current limiting capacity of those cables, they were not able to export. Now, the solution, what we have proposed on this, you can easily say you replace that cable, but if you replace that cable, there's a lot of downtime that you need to go, and then that will create more loss for your project. So we were, what we have observed, another thing, majority of the project in India, there are always some few terminals available in the combiner box or at the inverter level. So what we suggested to run a parallel cable system and terminate both end combiner box and the inverter, and obviously safety is the prime factor to do any intervention at site. Connect both end during low irradiance hour, afternoon, and then that has not only uplifted but maintain the sustainability for that design error that was observed throughout the life of the project. That's one example. Another example, connector. I'll give you particularly why connector is very common in India, connecting to small 4 square mil cable. Sorry to being a little technical, and then 1 6 square mil cable coming out. That Y connector is one of the weakest link. So I suggest you do investigate whether, even though from outside they looks all connected, but not necessarily they're connected inside. So what we have done all thermal scanning with our handle infrared inspection, and we have observed one side of the Y was hotter than other side. So that's clearly reflect that connections is not very done properly. So checking, investigating, and might be replacing those Y connectors, because they doesn't actually cost you more than the loss of revenue that you are incurring off your system. Sometimes inverter, for example, inverter comes with some level of insulation resistance relay setting, and there is a range within which this insulation resistance operate. So check your OEM, inverter manufacturer's recommendation. What is the range given? And you can adjust the settings of your inverter to its maximum level. That may allow in the morning. I'll give you again another example. We have done a few scenarios like this. It allows half an hour early to start in the morning when there is a humidity or fog in the morning. Minor cable damage would always be there. If you say that 100% no error on the cable, that's not real, because we all need to understand and appreciate the practical challenges when the construction happen. So some level of error, some level of damage may happen on those cables, and that is why this range is given. But don't go beyond that allowance or limited range given by the OEM. Otherwise, you will breach the inverter warranty. So few pragmatic points. So how do you really identify? So that is why more pragmatic approach that we take, by taking into account as that whether the design that went in are appropriate or not. So from our experience, what we see, the reason for error are coming from design, from a poor construction practice, and some lack of O&M activity someone is doing.
Thank you, Mr. Jyotiroy. We'll take one last question before
Please.
we move ahead with the next presentation. So Mr. Suresh Kumar has asking how we going to mitigate EV vehicle increase with, sorry, the question is, 1 minute. How we going to mitigate EV vehicle increase with present power infrastructure? How we are going to mitigate EV vehicle increase with present power infrastructure?
Very, very burning question, very valid question. I'm assuming the question is related because we already have some disturbance in the grid network, and more penetration of EV that will create more disturbance. You are absolutely right. So that is why few solutions, whether time shifting, what is happening at the moment in the UK, there are certain mechanisms are actually putting forward that certain customer can charge their vehicle at certain window. Because what happened if we all come back home during evening, and we all plug in our charger at the grid network, then all of a sudden your demand going to go significantly higher. So there's a huge mismatch of demand management scenario is going to happen. So to really address this issue, because we know that deployment of EVs is increasing exponentially day by day, but grid infrastructure is not necessarily following that path to improve or to accommodate this potential growth of EV. So that is why policy framework is absolutely necessary, where utility companies, different stakeholders, different key stakeholders to come together and create that charging infrastructure mechanism purely from grid connected charging point of view. This is one scenario. Other scenario, you could always be off grid. For example, with demand going to increase for battery storage, cost of battery storage is declining. So with this trend, we could have an off-grid system where dependency on grid can be avoided. For example, the ISC Bangalore project that we mentioned, there are three-wheelers. They were charging, and they were previously charging just in a power socket. The power quality of the existing grid network was not necessarily quite good in terms of its voltage, in terms of its current value that is coming to charge that vehicle. So that is why when they were charging in our station, they get stable voltage, they get stable current. The charging time for them was significantly reduced. So you could have another parallel option by integrating solar and storage and be off grid without dependency on grid, which will make you, even the concept that we are trying to actually resonate here is rather than net zero emission transportation. So I could see two major ways to address this potential problem that we are going to face with huge penetration of EV in our network. And again, it is not really India specific problem. This is a global problem because the EV penetration is happening across the globe, and not necessarily utilities are well equipped with in their planning to accommodate that.
Thank you, Mr. Jyotirmoy, for the wonderful presentation. Over to you, Mr. Srivastav.
Thank you, Dr. Jyoti, for providing an excellent overview of the journey forward for net zero and the future trends and scope which is there. It was very interesting. Though I missed a part of it because of the connectivity issue, but it was interesting of interface with AI and ML. Also, the repowering of solar assets and then solar-powered EV stations, charging stations definitely would have helped us to understand how the things are changing in the world, and this is what is the need of the hour in future. That is what we have to do. Going forward, we go to the next panelist. Let me just introduce her to you all. She is Ms. Damini Chaudhary. Damini is the Vice President, Strategy and M&A at Schneider Electric India.
I think we have again lost Mr. Srivastava. Fine. Let me.
Exposure across manufacturing, services, and technology sectors also. Global perspective with hands-on experience in developed as well as emerging markets. With this, I would like to request Ms. Damini Chaudhary to deliver a presentation on solar EV and energy storage. Welcome, Ms. Damini.
Thank you. A very good afternoon to all of you. Am I audible?
Yes, you are. Yes, you are.
Yes.
Just going to pull up the presentation. So if you could bear with me for a second. If you could just give me a light confirmation on whether the screen's visible and if you could hear me well.
Yes,
Yes, it's quite visible and you are.
Super. Thank you. A very good afternoon again. I would like to thank CII. I would like to thank IGBC for giving the opportunity to Schneider Electric to come and talk about how solar, EV, and storage is helping shape the energy landscape of the future. So pleasure to be talking about. You've already introduced me, so I'll just jump straight into the presentation. Okay, something. This is a short reminder about who Schneider Electric is. So Schneider Electric, we are a global leader in energy management and automation. Our stats speak for ourselves, but we are a large company with presence across the globe, distributed presence across the globe. We work in key end markets like energy management sectors. We work with buildings, we work with data centers, and we do large part of our work in industry automation as well. I would not spend a lot of time in talking about who we are, because I'm sure that a lot of you would be familiar about who Schneider Electric really is. Let me go straight into the topic on which we want to talk about today. How, with this ever evolving energy landscape, we should think about storage, we should think about renewables, we should think about electric vehicles. So we know that when we talk about India and the journey that India has had in the last 10 years, that the journey will be very, very different for the coming 10 years or for the coming 20 years. We are going to look very different as a country in the next 20 years. If I just take an example and a cut off up to 2030, we will potentially see 30% more buildings and more households in India. We've just had Mr. Jyoti talk a lot about electric vehicles, and there were questions that we discussed on electric vehicles. We know that we see a large boom coming into the market on electric vehicle side. Today, EV penetration is just 1% in the country, whereas if we benchmark it with Asia, if we benchmark it with China, those countries are sitting at 30% EV penetration. And we are also talking about EV penetration going up to, the targets that India has laid up for itself. We are talking about countries' EV penetration also moving towards that 30% range by 2030. So what does all of this mean for us? More buildings, more households, more electric vehicles on the road, more industrialization, that we have put ourselves target as that industrialization should contribute to 25% of GDP. All of this means that the energy demand is going to increase by 2x, and I'm talking about energy. Then we translate it into electricity. We are saying that this would yield into a 6 times more electricity demand. Okay. And we are also talking, as a country, we have taken bold ambitions towards net zero. We have also laid targets for ourselves that 75% of the electricity demand and the electricity growth that we see in the country should come from renewable sources. And also, not only this, so we are just talking about the demand side, but we're also saying that the 25% of the electricity that gets generated should then be generated from local distributed generation sources. So these are some of the stats that we see hovering around today in the country. Different publications, sources would talk about these stats. All of this means that the electricity and the energy landscape is going to evolve big time in the future. And we as a country, we as a company playing in this particular field as a huge opportunity to play and contribution to make. Just again taking a step back to see what are the additional net zero goals or green goals that the country has put for itself. We call it the 5 elixirs or the Panchamrit goals. We're talking about, sorry, 1 second, I'm just getting some weird pop-up on my screen. Okay, we're talking about 500 gigawatts of energy being produced from non-fossil fuel sources by 2030. Okay, if we just talk about solar, the capacity that is installed today in the country is very, very small. By 2030, we are talking about reaching this to 300 megawatt. So ambition is 500 megawatt. Potentially, we would reach 300 megawatt. Opportunities there. We are talking about renewable energy meeting 50% of energy requirement by 2030. And I will come in a bit to talk about what is the energy requirement that the country sees. We're talking about reducing the carbon emission by 1 billion tons. And we're talking about that eventually we as a country want to become a net zero economy, a net zero emission country by 2070. On top of it, and in order to take this more and more seriously, we know that the government and the stock exchanges, they have introduced rules for top 1,000 listed companies, top 1,000 companies in India to come out with their sustainability reporting. All of these is indicating that the goal is real. We want to take measures towards becoming green, towards becoming carbon neutral. And when we talk about becoming green, when we talk about becoming carbon neutral, energy efficiency automatically comes into play. Not only energy efficiency, but also clean energy, energy generation, energy transmission, energy distribution, and energy consumption. All of these are the terms that link together, which would help us as a country become a net zero country by 2070. This is the energy outlook of our country. Okay, so if we look at the mix of the country today, we are talking about that we have a capacity of about 417 gigawatts generation today. Majority of it is, if you would see, is coming from non-green sources. Okay, so fossil fuel sources contributes to majority of the energy mix. Solar per se, if I just pick up solar is only contributing to 67 gigawatts of the installed capacity. The expectation for 2030 is, of course, the consumption is going to increase. So we need to increase the installation and the capacity to serve the country's energy needs. So the capacity would go up to 700 plus gigawatts, but solar within there is only going from 67 to 293 gigawatts. Now you may argue that, by the way, this is already a 4.4 times growth, whereas the overall installation capacity is only going to increase by 2x. But the question that we have to ask ourselves that is 4x enough? Okay, and do we really peg it and benchmark it versus the overall growth that you would see in the energy side? And why this question, right? Why this question on solar? The question is, can we do more in solar? The answer is yes. Why do we do more in solar as a country? Because we, based on assessment, we are a country which has a capacity of going up to 750 gigawatts of installed capacity on solar. Why 750 gigawatts? Because we are a country which has abundance of sun. We have plenty of sunlight available throughout the day in most of the regions. And you see the map of India with some grading on where there's high potential, where there's low potential. But pan India, if you look at it on a pan India basis, on an average, we have 300 and plus days of sunshine available across the country. If we take a day, the 24 hours available during the day, we get in a day 7+ hours of sunshine available to us. And out of the 7 hours, 55% is good quality sunlight. The terrain itself is spread over 3.2 million square kilometers. All of this basically says that the potential to have solar installed capacity in the country is 750 gigawatts. Whereas if I link back to the stats that I just showed you previously, we are saying that the country would go only to a 300 gigawatt by 2030. The target on renewable, which we as a country have taken, is 500 gigawatt. Okay, so 500 target, we potentially will reach around 300, but the capacity available based on our terrain, our topography, and our geographic location around the world is 750 gigawatts. So why, when the capacity is available to address 95% of our country's energy needs, why are we only restricting ourselves to a 40% utilization? This begs the question, that is 40% utilization the right number to look at? And why are we restricted today on 40%? So we take a step back again and ask ourselves the question that, what is holding us back today? What we as a country, as a company which is focused in this area, you as an audience who are very interested to work in this space and to learn more about this space should do. But there are 3 key questions that come to our mind. Number one, how do we make sure that we are optimizing the fossil fuel production and replacing it with renewables? Number 2, how do we make sure that we are reducing the transmission losses? And there are multiple stats that you can talk about in transmission losses. I think on an average, we as a country operate with about 19% transmission losses still. So is 19% the right number to live with? On one hand, you spend a lot of money to produce energy, and on the same time, you lose about half of it when it comes to the consumption side. And 3, given the sheer opportunity available to us on solar production, on solar installation, what should we do in order to maximize the solar production? The answer is that we need to work very, very actively, and we need to think actively towards transforming the energy landscape. So then how, the question is, okay, how do we transform the energy landscape? So again, when we talk about the energy landscape, I go back to the point that I made earlier that we are talking about three key aspects. We are talking about generation, we are talking about transmission, and we are talking about distribution. Naturally, when you talk about generation and transmission, the only thing that comes to your mind is utility. And when you talk about consumption, distribution, the only body that comes to your mind is the consumer side. So let us break it down into utility and consumer and talk about what can a utility do, what do we need to do to work with the utility in order to make sure that it is able to move towards this energy transition. And then we will come and talk about how can we enable consumers in order to participate in this opportunity of solar EV and storage that we see in the country. So utilities today, okay, if we take utilities today are very traditional. They have been working largely on fossil fuel based production, but they are improvising themselves. There is a big change that is happening in the utility space that we see that has never happened in the past 100 years. It's decarbonizing in front of our eyes, and there is a boom coming in this space from electric vehicles, from the change in hardware, because of renewables, because of capacity generation. This means that the grid needs to work very actively in order to become scalable and resilient. Okay, scalable, which means that it needs to have appetite to absorb this different distributed and renewable energy resources that are coming to it, and resilient because it needs to make sure that it is able to manage the load that will come because of, again, these different plug play solutions that are coming into the market because of load, for example, that electric vehicles will place on the system, and because of different generation sources now being attached to the grid. We also need to think about how, as a country, as a regulatory body, as government, we can actively think about working towards a capitalized model and making sure that the benefits of generation are being passed on to the consumers. And when I say benefit of generation, it means that if we are talking about decarbonizing the grid and moving away from fossil fuel to, let's say, a green hydrogen or to a battery-based solution, the benefit of these lower cost resources are also passed on to the consumer, so that we are promoting active customer incentivization, which will then convert into a prosumer model. Today, the average cost of electricity, if you go to any state, if you go to Maharashtra, it's around 7 to 8 rupees. In South, it is again around 7 to 8 rupees. In West, it is a little bit cheaper. Is there a way to reduce the cost of electricity for the consumer by decarbonizing the grid itself? So that is a question that we have, so that the utilities, instead of becoming a network operator, they move towards a service provider and a platform provider sort of a model. What will happen because of this? You would have fixed the grid problem. The grid would become scalable. The grid would be resilient to take care of different types of load profiles coming in, but we are also incentivizing the consumer. And the moment you bring consumer into this equation, a consumer becomes smart, and the consumer would actively think about not only just being a consumer of electricity, but also about being a producer of electricity. And this is where solutions like storage, solutions like microgrids can come in and can also help the consumers move towards more and more home automation, more and more smart homes, and think actively about not only being a consumer, but about being a producer of electricity, as well as also thinking very actively about energy efficiency. End to end, we are talking about a digital journey, both from a utility side as well as from a consumer side, so that you move beyond the meter story, but also talk about an end-to-end digitization and connectivity. Let's talk a little bit more on the demand side, right? Okay. So supply side, okay, solar will help come on the supply side, but what can a consumer do on the demand side? On the demand side, what can an industry, what can a building, and what can an infrastructure do in order to adapt all of these evolving landscape that we have in energy and move towards the future? So we ran a small study, and the information that you're going to see on this page is based on some CXO data that we've collected. So the first point, okay, if you talk about the basic that comes to your mind is, okay, how do I make my energy green? Okay, so you talk about the supply side. Okay, it's very easy to switch from if you have a rooftop, if you are a consumer, you live in a building, and you say, okay, I can put solar on my rooftop and I can change my energy supply and I can become green. Okay, so and again, based on the data points that we've seen, we say that by purchasing renewable energy, you can address 56% of your energy and move towards the green solution. This addresses scope 1 and scope 2 of the energy emission journey. The next step is, okay, you move to a greener energy supply side. The next question comes that how do you consume energy more efficiently? And that's where you start working towards energy efficient solutions. You start working towards circularity. And if you, for example, drive circularity, you would have addressed 40% of your energy cost. You can reduce 44% of your energy consumption by deploying energy efficient solutions, by, for example, doing energy audits in the system, and just by making sure that you have energy efficient apps and end-to-end digital solutions deployed in your system. And then you can electrify by electrifying, by adding electric vehicles to your network, to your infrastructure. You can again save energy consumption and work towards load management. All of this together, so it's about supply side, so replacing energy with green solutions, working towards cost efficiency and circularity, and working towards electrification helps us overall meet the sustainability goal. Let's take a look at a small video in terms of how a customer can work in contributing towards this smart journey using all of the solutions that we have spoken about. So I'll try to play the video. Is it possible? So this video was an example of how we can work with behind meter connectivity, and how at the home level, at the consumer level, we can help control the load, we can help manage the EV charge, we can help work around the storage solution and work together with the grid to make sure that there is efficiency all around in the system. I'll move on. We'll talk a little bit about storage, right? So we have talked a little bit about solar and how solar is important. We have talked about how the grid needs to become more and more resilient because electric vehicle penetration is going to increase, and then it will lead in terms of demand on the grid. It will lead to requirement on the grid to work very, very actively on load management. But there's a lot of chatter around battery, right? There's a lot of chatter around storage. So what does storage mean? And when when anybody talks to me also about storage, the natural instinct is, oh, storage is battery. The question is that the right way to think about storage? And you know, maybe our mindset is being guided by the type of things that we see are available in the market today. So when we look at storage, we talk about lithium-ion battery solutions, we talk about lead-acid battery solutions, which of course is not green. And recently, we are also talking about sodium-ion battery solutions. The question is that all of these solutions, you know, when we talk about battery solutions and the technologies that are available today, are they really green? And Jyoti talked a little bit about it. Are they completely green? Do they not carry any environment hazard? And then, therefore, naturally, should we shift to that storage solution? So leaving the cost apart, okay, because I'm not addressing the cost part of the solution that is available in the market today. Of course, there is a lot that can be done in the cost, but just sticking to the technology part of it, the question is that with the solutions available in the market today, is that the right technology to use and to switch to, knowing that the resources are limited? It's not totally green solution, considering the amount of water that is used. For example, if I take an example of lithium-ion battery, 1 ton of lithium-ion battery, mining of lithium, it requires about 500,000 gallons of water. So that is the equation that we are talking about. Plus, we know that when we use battery, there are different transmission losses that we have to work towards. The battery's life gets deteriorated as in when we use it. So life at 1 year and life at the end of 5 years. And the efficiency of the battery of a 1-year-old battery and of a 5-year-old battery is very, very different. And then we know that as the country, we are struggling with circularity of battery. It ultimately goes to a landfill. With all of this, how should we think about storage? You know, that is a question that comes to my mind, and that is a question that we as a technology company are also trying to solve, to understand that how do we think about storage. And we say, and the answer that we get is that when we think about storage, of course, we keep in perspective the solutions that are handy, and we try and work towards how to make them more and more efficient to diminish the transmission losses, to diminish the losses that happen because of the deterioration in the battery. But at the same time, we also have to very, very actively think about clean storage solutions. An example of clean storage solution is green hydrogen. So, for example, you produce. Let me first explain how would the storage work and how would you use the storage. Let's take an example of microgrid. Okay, so you would produce sun energy from solar, which is a direct current. You would then somehow try to store it in the battery so that you can use the power from the sun when, let's say, grid is not available. That's typically an example of how a microgrid would work. But to store the energy from sun in the battery today, you have to convert DC into AC. AC feeds into the battery, and then there is a lot of losses that happen in between. If there is a way to store the DC current in the form of a DC current, then it would mean that you've already optimized the system in a bit and you have saved on all of these transmission losses. An example of how to do that, it's possible through green hydrogen. So working towards digitization, working towards new technology solutions in storage, and working towards grid resilience, all of this would help us to make sure that we as a country are able to maximize the usage of renewable energy. So storage definitely is the way to go. We have to work towards smoothing the waves, and we have to actively explore more and more clean storage solutions. This means that when we think of the energy landscape, we are talking about the entire digital ecosystem, which is changing. The energy ecosystem is changing. And again, linking it from generation to transmission to distribution, we are talking about an ecosystem where we would have smart homes. And I showed an example of how smart homes would look like. They would connect to a cloud and through EcoStruxure solutions with the grid, so that the grid is able to be resilient and scalable. You would then have participants in the form of consumers like us who would become producers. So producers who would use solar to generate power, who would store power using some sort of a storage solution, who would electrify by going into their electrification journey, and at the same time digitize for cost efficiency. And we at Schneider Electric are working towards delivering all of these solutions. We have solutions towards offering grid optimization. That's where our EcoStruxure basket comes in. We provide flexibility services through our AutoGrid offers, and we make sure that we are able to work with prosumers using our software and cloud technology through our applied solutions. So end-to-end, the working towards distributed energy resources, working towards decentralized systems, decentralized energy generation and management. This is what the landscape of the future would look like. And this is when we would be able to integrate solar, battery, as well as electric vehicles, which are the buzz of the town.
The grids of the future start.
Sorry. I'll play one more video, which will evidence live example on how the transformation would look like.
The grids of the future start here. With buildings that generate and store their own energy. Wait, let's start over. The grids of the future start here. With the exponential growth of EV infrastructure. Hold on a sec. They start here with solar and wind farms. And here with real-time control systems. And here with digital twin-enabled modeling. And you know what? Grids of the future start wherever the energy transition is unfolding, which is pretty much everywhere. They help utilities manage complexity and maintain balance, using digital solutions to avoid disruption and innovative technologies to reduce emissions. And just so we're clear, future doesn't mean in a year or a decade. We're talking future ready today, increasing safety and security, empowering cross-team collaboration at the right time, and unifying data across the life cycle. So grid operators can deliver reliable, sustainable energy. And build it for life.
So I'll end my presentation with 3-4 key messages. Number one, solar is available in plenty in the country. We should encourage everyone to be a solar farmer to the extent possible. This will help us address 90 to 95% of our country electricity needs coming in the future. We have to make sure that we are working towards efficiency, okay? And efficiency, there are various efficient, energy efficient solutions available in the market. We have to make sure that we scale soft loops, we avoid transmission losses, that will help us enable technologies, electric vehicles, batteries, etc., better into the system. We have to actively work towards discovering new and clean storage technologies while adopting the existing ones. And last point, when we work on all of these three aspects together, that will help us transform the entire energy ecosystem. With this, thank you so much for being a patient audience. I hope you found it insightful, and happy to take any questions that you would have.
Thank you, Damini. That was a very good, very nice presentation. The solutions by Schneider. Also, the clean storage options with green hydrogen, because ultimately we will have to work it out. Batteries with a lot of common solution to it. And also that the consumer of electricity should be the producer of electricity. I think that if everyone can start understanding, definitely will make a lot of difference. We can just work it out, the questions. Can you just see it? I'm not able to see my chat box.
Yeah, there are a couple of questions.
Yes, one is saying fast here, the compliance not ready for faster turnaround. So technically, since we as a home, let's check it out. We as a home would be 3 kilowatt, 4 kilowatt entity for a discom. So higher scale of solar installation would need special connections and license. There is a question. Himanshu, you will have to help me out. I'm not able to get this chat box clear. My connectivity
Yeah. So yeah, I'll just read out a few. So there's a question from Ms. Swati. When we think about solar power generations, it is purely relying with the government norms, at least in the present day. Why is there a limit for a PV power generation domestically or by household level? If I want to install a PV on my house terrace, I need to go through a series of documentation and approval process with EB of local government. When will this be shifted? So basically, she's asking about the why we need to go for government approval and all. So what is the scenario change that you are what kind of scenario change in with respect to government approval and you see in this? You have any comment in that?
Yeah, so I think my colleague Roshan is there on the call to address some of the queries that come on the chat. He has addressed this to an extent, but let me just still take an attempt to it. It goes back to the point that I was making, that is the grid reliable today? The answer is no, we are working towards it. The government is working towards it. So imagine the 300 odd households, that 300 million odd households that we have in the country. If they all deploy solar at the same time, and if they all reduce their dependence on the grid, what would happen to the grid? The grid would become unstable. This would impact the power that goes into the industries, into the critical functions, and it would impact generation. And hence, why these approvals have been put in place, in order to make sure that the government is able and the utilities are able to calculate exactly what will be the impact on the load profile for the DISCOM, for the utility, and they are able to work around that. More and more smarter we become around this with technologies, the approvals will come down, and the government is very, very active in this area. And goes back to the point that technologies and digitization will help us in this journey. But yes, today the restrictions are in place because the grid is not very intelligent in order to work around the load management. It's working to get there.
Thank you. So there is one more question. Mr. S. N. Gupta is asking how to ensure grid stability with distributed generation.
This is a very tricky question, a technical one. I would probably ask Roshan if you want to address this.
Yeah, I think he has addressed in chat box just now. Roshan, would you like to?
Am I audible now?
Yes.
Yeah, you're audible. Yeah, please.
Thanks, Damini. I'll take that. So yes, Mr. Sengupta, that's a very valid question, because when we look at it from grid stability, there are multiple elements causing disruption. The first element, the more and more we have electronics, solar and DC-based power productions, there is an impact on power quality. So that's already causing a bit of instability. There is also dynamics of the load behavior, which is varying at the customer place. That is the second element. And thirdly, when you have more and more renewable being produced, which is again time bound. So there is a variation on the demand side. There's a variation on the distribution side. Secondly, there's also variation on the quality aspect of the power itself. So when I have to manage all of these, first pointer is how quick is my grid able to respond and predict the demand response pattern, right? This is what is achieved through advanced distribution management systems. So the last mile connectivity and the scale and span of the grid, when integrated together, the grid will be able to predict clearly what is the behavior pattern, and also given the right commands to the generating stations to reduce on the fossil fuel productions, probably ramp up the non-fossil productions, and also address the right needs for the peak load demands. So that's where the entire grid stability has to evolve.
Thank you, Roshan.
Thank you so much. And I think Roshan has already answered a couple of more questions in the chat box. So over to you, Mr. Srivastava. Yeah.
Thank you. I think that was a very interesting session. Both the sessions are very interesting. We are thankful to Dr. Jyoti and Damini for giving the presentations and making us more aware about how the storage is to be done, how the solar panels can be used with the EV charging points. What on behalf of IGBC, my colleagues and myself, we are very thankful to Dr. Jyoti and Damini for being with us for this session during this green building week. Thanks, everyone. Thanks for being with us for this webinar. Thanks, and let's say goodbye.
Thank you so
Thank
much.
you. Thank you, Damini. Thank you, sir. Thank you.
Thank you.
See you all tomorrow at 3 p.m. for the last webinar in this series of World Green Building Week. So tomorrow the entire focus will be on waste management and the recyclability of the material. So look forward to see you all tomorrow at 3 p.m.
Okay. Thank you, Anshu. Thanks a lot.
Thank you. Thank you. Yeah.